Hello, everyone. In this talk, we're going to walk through how we can build a high-performance CI/CD platform through standardization. My name is Mihir Vora. I'm a senior distinguished engineer at Capital One, and with me today I have Kamlesh Vaghela, who is a senior lead software engineer, and we both work on developer experience at Capital One. So, Capital One is a financial uh, company which is one of the top 10 banks in the US. We have a very innovation driven culture, and we are great at building products that our customers like. From a technology standpoint, Capital One has invested significantly over the last years in technology, and we are in the business of technology, which does banking. All right, so going back in time a bit, early days before even DevOps existed, I think it was primarily teams working in silos. I'm sure everyone remembers the days when there were specialist teams doing specific things, like server procurement, setup. There was a team that was doing QA or quality control. There was team dedicated to production support, and obviously there is the application development team. With this model work generally, despite our best efforts, we see quite a few instances where there was a lot of rework that happened. There was a lot of back and forth that happened between these groups, and there were plenty of opportunities in this enterprise workflow. What we would need is to break down some of these observed barriers between the development and operations. So, in order to bring the developers closer to the operations, the model that helps facilitate this is you build, you own. And with evolutions of architectures with microservices, it made a lot of sense to have this closer where the team manages the whole life cycle of delivery, starting from the build to release. So with the you build you own culture, obviously it empowered the developers to do their best work, but with that came a lot of responsibility and a lot of power as well. With more responsibility, the developers took that challenge and solved problems the best way they know how, and primarily that led to innovation, which resulted in building automations and pipelines which accelerated their software delivery. And this also evolved the DevOps practices, making everyone happy until the innovation created hundreds of pipelines. To make life easier for the developers, every developer went in and automated their problems, their functions, the way they thought was the best way to do it. This resulted in a lot of redundancy and also lack of standardization, where teams were solving problems, but they were not solving it the right way. In addition to that, I think the major problem that we saw with that was the governance requirements and the compliance needs that the organization has to meet. Every developer had to face that and solve that their way. We could quickly realize that this was unsustainable and we should transform how we would build software. So this the teams, those teams that develop thousands of custom pipelines, they naturally saw, given being part of those tech divisions or verticals, they saw the need to evolve it and rationalize their pipeline ecosystem, which led to multiple teams having to rationalize their automation that they built into some sort of a vertical group. And that led to like every division or every line of business or vertical having to do things their way. While this solve the problem of standardizing across teams and empowering developers, while this creates tremendous lift, we realized that was not enough. Um, if these divisions were able to create leverage, the next question we ought to think about is what can we do at an enterprise level? What else is possible? And then we realize that standardization, taking it to a whole another level, we can centralize the pipelines into a central pipeline platform. So all the goodness of all of these divisions doing things uniquely in their own ways had to come together and formulate an enterprise-wide platform that solves these problems head on. So we then realized the power of standardization with central platforms, how we build software in general. But what does that even mean? From the standpoint of CI/CD, what we anticipate is to have a uniform framework that pre-configures the set of core stages, consolidates things. That way, not all developers have to solve for it. It also helps solve for meeting architectural standards and patterns that are prescribed, or even best practices that are prescribed across the enterprise. But then it also solved the problem of alignment with the needs of governance and audit, and ensuring compliance centrally managed across the organization. Now, why would we even want to do this, or how would we ensure that the benefits are passed on to the developers and the teams so that they don't have to do any kind of heavy lifting to ensure that they can focus solely on doing their best work, which is developing features and taking the business forward. Uh, what the central platform provided was a lot of capabilities out of the box that where teams don't have to innovate. They don't have to spend time on uh, doing things that a central platform can manage, and they can innovate in terms of the business functionality or the products or what they can do for the customers. The central platform ensures that software releases follow a common standard. We ensure that the quality of releases are gated, appropriate peer reviews were happening. We streamline development practices and ensured that auditing and analytics was easier with the centrally managed ecosystem. While that was great, we started seeing the need for scalable pipelines that were built on the centralized platform, uh, and that would be covered by my colleague Kamlesh.
Thank you, Mihir. And hello, everyone. Centralizing a platform is a great first step. But as our usage grows, we need to think about scalability. Centralization alone can't handle the increasing demands of modern workflows. Let's explore why scalability is critical and how it impacts our ability to deliver efficiently. As more teams adopt pipelines, we often see what's called pipeline sprawl. This is when pipelines multiply across teams, leading to inefficiencies, redundancies, and inconsistencies. With more pipelines comes more complexity. Managing and maintaining this becomes significant operational burden. Think about versioning, dependency management, and compliance. These are just few of the challenges we face. Finally, let's talk about the optimization. It's not just about speed. We also need stability and efficiency. Let's discuss how we can streamline our pipelines, reduce bottlenecks, and ensure reliable deployments, all while maintaining a balance between these critical factors. Let's start with the parallel execution. Running tasks in parallel can significantly reduce the overall pipeline runtime. By identifying independent tasks and executing them simultaneously, we can speed up delivery without compromising quality. Optimizing resource usage is critical for cost efficiency and performance. This means allocating just the right amount of compute, memory, and storage for each task to ensure we are not over-provisioning or underutilizing resources in our pipeline. Failures are inevitable, but how we handle them makes all the difference. Failure-aware pipelines uh, are designed to detect, isolate, and recover them errors quickly. We can build a resilience into our pipelines to minimize downtime and maintain reliability by using techniques such as feature toggle, faster rollback capabilities, and observabilities. Observability is key to understand what's happening in your pipeline. With proper logging, metrics, and tracing, we can gain insights into performance and identify bottlenecks. Pipeline analytics can help us make data-driven decisions to improve pipeline efficiency. Finally, let's talk about optimization techniques. From caching and dependency management to reducing redundant steps, there are many ways to streamline pipelines. I will walk you through some best practices and tools that can help us achieve faster and more reliable workflows. Parallel execution is a game changer when it comes to improving pipeline throughput. By enabling parallelism, we can significantly reduce the time it takes to complete workflows, leading to faster delivery cycles. The key here is identifying independent tasks that can run simultaneously in parallel. This allows us to maximize resource utilization and avoid bottleneck in the pipeline. However, achieving effective parallelism requires careful dependency analysis. We need to ensure that tasks are truly independent and that dependencies are properly managed to avoid conflict or pipeline failures during execution. Optimizing resource usage is essential for maintaining both cost efficiency and performance. Let's talk about how we can balance resource demands across pipeline to avoid overloading or underutilization of our infrastructure. One way to achieve this is by setting limits on Jenkins agents. By defining these limits, we can ensure that no single pipeline monopolizes resources, allowing for smoother operations across the board. Pooling agents centrally is another effective strategy. This approach allows us to share resources dynamically among pipelines, improving our overall utilization and reducing idle time. Allocating resources just in time is key to efficiency as well. By provisioning resources only when they are needed, we can minimize the waste and ensure that the pipelines are always running at optimal capacity. Finally, enabling performance observability is critical. With proper monitoring and metrics, we can gain insights into resource usage patterns, identify bottlenecks, and make data-driven adjustment to improve efficiency. Downloading artifact dependencies can be a time-consuming process, especially when multiple agents or applications repeatedly fetch the same dependencies. This can slow down the overall pipeline execution. To address this, we can implement a caching layer on top of Jenkins agents. This shared cache allows agents and application to reuse previously downloaded dependencies, significantly reducing the redundant downloads. By introducing this caching mechanism, we also reduce the load and dependency on the artifact management systems like Artifactory or Nexus. This not only improves the performance, but also ensures better resilience in case of connectivity issues or service outages. Failure handling is not something to add later. It needs to be part of the design from the very beginning. This ensures that our systems are resilient and can handle unexpected issues effectively. Fast failure is critical. The sooner we detect an issue, the quicker we can address it. This minimizes the impact on the overall system and helps maintain smooth operations. Incorporating retry logic ensures that transient issues don't cause permanent failures. Additionally, graceful degradation allows the system to continue functioning even if some components are temporarily unavailable. The goal is to protect the stability of entire system. By isolating failures and preventing them from cascading, we can ensure that the system remains operational under adverse conditions. Finally, failure observability is the key. With proper monitoring and alerting, we can gain insights into failure patterns, identify root causes, and continuously improve the system's resilience. This optimization patterns collectively enables a pipeline architecture that is both flexible and resilient, perfectly suited to support exponential business growth. By using standardized, reusable pipelines, we ensure consistency across teams while still allowing the autonomy needed to address specific requirements. This balance is key to scaling effectively. Techniques like parallel execution, dynamic resource allocation, restartability, and robust end-to-end failure handling not only accelerate delivery, but also enhance the reliability of our pipeline. Finally, centralized management and analytics provide the control and visibility necessary to foresee thousands of pipelines, ensuring smooth operations and informed decision making at scale. That's all I wanted to discuss today. Thank you, everyone.